Hello, my dear student. Today I am going to start a chapter that is based on gravitation. The chapter name is Gravitations. The chapter name is Gravitation. So before going to start deeply about this chapter Gravitations, I want to tell you about certain thing that is known as force of gravity. Force of gravity. Do you know, my dear, in daily life we are observing that if any object is thrown in upward directions, at the end it attains a certain height that is called maximum height and it falls back towards the earth's surface. Why it is happening? We are not even thinking why it is happening. This is only because of done due to the force of gravity. Now what is the meaning of force of gravity? The force of gravity means a certain force of attractions exerted by the earth on an object towards its center. This is known as force of gravity. So that the reason behind it, if any object has thrown in upward directions, it will comes towards its center. Now the next topic is force of gravitations. Force of gravitation. Force of gravitation. Now what is the meaning of force of gravitation? When Newton came across this concept, he told first of all, in the universe, two bodies are attracted with each other. This is just because of, the force of gravitation. Due to heavenly bodies contain a huge amount of mass. Because gravitations can be actually applicable in the heavenly bodies just because of it retains the heavy masses. That's why Newton given us certain laws. That laws is known as universal law of gravitation, and also it is known as Newton's law of gravitation. So this is known as universal law of gravitations, or Newton law of gravitation. Newton has taken the two bodies. First, a body of mass m1 and second body of mass m2. It is kept at a certain distance r apart from each other, and that distance has taken from the center of these two bodies. That is, this is a center point. Center point, or you can say that center of mass. That means in which the matter of whole bodies can be concentrated, and that this is the reason behind it. Gravitational force is known as central force because it is act line joining these two centers of these two bodies. So you can say that this is the line joining in between the two bodies, center of two bodies. Now he proposed that when the two bodies are kept at a certain distance r apart from each other, then a certain force of attractions F is exerted. This certain force of attractions F is directly proportional to the product of the masses of the two bodies, that is F proportional to m1 dot m2. This is first equation. And the same force of attractions is inversely proportional to the square of the distance between the two bodies, that is F proportional to 1 upon r square. This second equation itself known as inverse law equations. Inverse law equations. Now, when we combine after combining equation first and equation 2, we get f proportional to m1 dot m2 upon r square. Now, when you remove this proportional sign, we get that f is equals to g m1 m2 upon r square. Therefore, g equals to f r square upon m1 m2, where g is known as universal constant. G is called universal constant. Means in the whole universe the value of g is same. That value of g has given by Sir Henry Cavendish with the help of two golden balls hanged with the help of Triton balance, and he has given that the value of this g, we can say that the value of this capital G is equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is the unit of capital G. But we can simply find the value, this entire unit of this capital G. You know what? As we found that G equals to f r square upon m1 m2. So we can say that the unit of f will be Newton. The unit of r means the length on the radius, so it will be meter square, and the SI unit of mass will be kg into kg, that means kg square. So ultimately we can say that it's a Newton meter square per kg square. And its dimensional analysis of capital G will be, you know what, the dimensional analysis of force will be m l t minus 2 into radius, it is what, l square, and then mass will be m dot m means n square. So ultimately we can say that this will be gone up, so we can say that m power minus 1, m power minus 1. Now here is l power nothing means 1, l power 2, so it will be l power 3, and here is t to the power minus 2. But you know what, the dimensional analysis of force I have taken directly. But do you have any ideas how to find out the dimensional analysis of this force? Because we know that the force F equals to, you know what, ma. Force equals to ma. एक बच्चा जब पैदा होता है तभी से माँ बोलना सीख जाता है, तभी से वो फिजिक्स सीखता है. F equals to ma. Now this m stands for mass and a stands for acceleration. Now the dimensional analysis of mass will be m and acceleration will be l t minus 2. How came? Because this acceleration should be, you know what, if you reduce these accelerations, so we know that the rate of change of velocity is known as acceleration. It will be, you know what, m into accelerations velocity upon time. This is the splitting of this formula. Again, if you want to split the formula of velocity, so we can write, you know what, mass into velocity will be a rate of change of displacement. That should be displacement divided by s. Okay, so s upon t into 1 by t. So ultimately we can say that it will be mass into displacement upon t square. Now the dimensional analysis of mass will be m, displacement will be l, and t will be t square. So ultimately we can get that mlt minus 2. This is the dimensional formula of force. That's why directly I have written over here, it's the mlt minus 2. Okay, now when we involve the dimensional formula of force is mlt minus 2, and after the radius itself known as the length, so it will be l square and divided by mass into mass. So dimensional analysis of mass will be m into m, that is square. Ultimately we got m power minus 1 l cube t power